Hey everybody, and welcome to our very first Android Code-Along. I'm Karen, an engineer on the Android Developer Relations team.
Hi everyone, I'm Manuel, also an engineer on the Developer Relations team. Thank you so much for joining us today. In this Android Code-Along series, we will be live coding different programming challenges you will face as you progress as an Android developer. So here we are, so that you can get a better understanding of how we recommend approaching those challenges.
Yeah, so as Manuel is coding along, feel free to pull up Android Studio and also follow along, or you could feel free to just watch and do the collab yourself a little later. We're also going to be looking at the live chat, so if you have any questions, feel free to ask it in the live chat, and we'll try to answer as many questions as we can.
Yeah, thank you so much. So the first topic for this series is going to be coroutines. So I'm going to be coding here on my laptop. So please feel free to code along with me, or actually with us, and ask as many questions as you have. We'll be very happy to answer them. So if we move to the laptop here, I hope it's being shown, right, Karen?
Yep, yeah, and we already have a great question coming in. So Zin asks, is this going to be for someone who knows nothing about coroutines?
Yeah, definitely. You are in the right show. We are going to assume nothing. So basically, we're going to start from scratch, assuming that you have like some sort of Android background here, like you know a little bit what we are trying to achieve, things like what happened when something is running on the UI thread. But regarding coroutines, you don't need to know anything right now. We will explain everything in this session. But thank you for the question. Cool. So basically, whenever I want to learn about a specific topic, and in this case, it's going to be coroutines, I go to developer.android.com and I search for the topic. So in this case, it's going to be, I don't know, let's say coroutines, for example. So here, basically, the top search is going to be Kotlin coroutines on Android, which is actually our documentation. And as you can see, we have a pretty detailed guide. So we have, for example, like features, how to execute things in the background thread. And apart from this, we have also additional guides for this. So we have different pages. If you see here on the right side of the screen, we have few things that are going to be quite useful. So for example, we have best practices, we have additional resources, we have things like Kotlin flows as well that we might not get into in this session, but they are definitely good resources to check out on your free time. So basically, we are going to be talking about coroutines. And actually, coroutines, if you take a look here, is our recommended solution for asynchronous programming on Android. That's why, because in the past, asynchronous programming is quite a complex topic to face. And coroutines really simplify how we approach and solve these asynchronous tasks. And one of the features to mention, for example, is that they are lightweight. And for example, you can run many coroutines on a single thread because they don't actually block the thread. They suspend the execution, and we will see later, and we will understand better in a second. It actually has lower chances of creating memory leaks because it has something called structured concurrency, where all these operations and block of code that you're going to run are going to execute in a specific scope. And whenever that scope goes away, for example, you are navigating away from the screen, all those operations are going to be canceled. Also, it has a pretty good built-in cancellation support. This is something that other alternatives like Callbacks suffer from. So in Callbacks, it's quite difficult to handle cancellation properly, and Coroutine actually provides an easy way to do so. And my favorite here is Jetpack Integration. So we have a lot of things covered with Coroutines. So we have view model, we have room support for your database. We have so many things, for example, work manager as well. So we will see how everything plays along pretty well. So if you go through the guide, you will see all the explanation. This is kind of a little bit of theory behind it. But actually today we want to complete or actually go through the code lab. I don't know if we have time enough to complete it all. But something I want to mention, for example, if you're really new to coroutines, there are some people, we have this additional resources page where we have things like specific topics like basics, cancellation, exceptions. And there is this first things first blog post that actually teaches the basic coroutine concepts. And probably I'm going to leave it open in case we have to come back to this later, because it explains things like what's a coroutine context, what's a coroutine scope, and all that. Okay, stop talking. Let's code a little bit. So I'm gonna leave it open as well. So basically, now we are gonna go through the code lab. So something we can do is try to search for the Coroutines code lab here. Basically, if I do that, I get a few results. So we are gonna go through the basics, which is this result here. But we have multiple Coroutines code labs. Apart from the basics that we are gonna go through today, we have the advanced Coroutines code lab, which is this one here. And also, apart from the training courses, we have another one, which is building a Kotlin extensions library code lab. And this one is basically whenever you have non-coroutine code, how to create a bridge to convert it to coroutines and having like a more idiomatic coroutine version of that specific API. So here we explain APIs like suspend cancelable coroutine or callback flow that we obviously don't have the time to cover today. But yeah, let's open the code lab. I have Android Studio as well open, so if you want to code along with me, feel free to do so. And so here, basically, CodeLab is just a like self-paced guide for you to actually code and run an application that is going to teach you about a specific topic. So this one is about coroutines in your Android app. And basically, code labs kind of follow the same structure. And the first one is gonna be like before you begin, or kind of like an introduction section. And here we are just trying to set expectations. Like, okay, this is your first introduction to a specific code lab. It's like, what I'm gonna learn. Am I in the right place or not? So here we're gonna say, okay, we're gonna go through Kotlin coroutines. You are gonna learn about that. Some prerequisites, for example, like you're familiar with view model, repository layer and all that, room database. You are familiar or have some experience with Kotlin, and basically the things that you will do.
Before we jump in too much, we had this question where someone was wondering, what exactly is coroutines? So what kind of use cases are coroutines useful? And should they be thinking about coroutines as a replacement for ArcsJava or ArcsKotlin? What is the official guidance here?
Yeah, so Coroutines is our recommended solution for asynchronous programming. And when we talk about asynchronous programming, it's basically kind of the opposite of synchronous programming. Synchronous, whenever you want to run something synchronous, it's like basically, I want this to be run right now. I don't want to wait for this. Asynchronously means that I want to run something. Probably it doesn't need to go to the Android UI thread, of course, because there are some operations that need to happen in the background so that we don't block the UI, because we want to have a responsive application. So with asynchronous programming, it's like, okay, we might want to run something on a different thread, but also I want to execute something on this same thread, but I don't want it to happen right now. Or better said, I don't mind if it's executed like, I don't know, 50 milliseconds later because something else is being executed. So it's basically a way to run a piece of code, as we will see, that could even happen like in any thread, but doesn't need to happen right now, and it doesn't need to block the thread. I hope that's clear. And regarding RxJava is also a solution for asynchronous programming in Android, and it was pretty popular in the past whenever coroutines weren't there. But at Google and Android, we recommend using coroutines for this specific use case, because as I was saying, like all our Jetpack libraries are really well integrated with coroutines. Cool, thanks for the question. Okay, so getting set up, this is another section in our code labs that pretty much all our code labs do the same. And here, basically, it tells you how to download the code and how the code is structured. So for example, the Coroutines code lab, we will see later in Android Studio, it has a project that you download. And in the project, there are two Gradle modules, one with the start code, another one with the finish code, just to make sure that you want to make sure that you follow the code lab properly, or if you get stuck, you can see the solution there. But this setup totally depends on the code lab author and also the project that that we are in charge and we are trying to solve. So for this specific use case, this setup works pretty well, and that's what we've been using now. Okay, let's move on to Android Studio. So basically, here we are going to see an application. Kotlin Coroutines is called, that whenever you tap on the screen, a message is going to be displayed. So I have here Android Studio that I can run the app. So as I was saying here, Android Studio, we have the start package, the module with all our code. In case we wanted to check out the solution, I would go here through the finished code Gradle module. And I also have my emulator open. So here I can see like the application. Whenever I tap on the screen, it's gonna load. Like you are gonna see the loading spinner there, and then it's gonna count how many times you've been tapping on the screen. So here it says 2 taps, and then kind of the title or the message on the screen is gonna change. So basically, what we are gonna do, we are gonna see later in the code that asynchronously, we are gonna make a request to update the number of times we've been tapping on the screen, and that's gonna be communicated to the UI, but also something else is gonna be loaded in the background. And if we take a look here at the code lab, it explains how the app is architectured. And this is kind of follows kind of the classical pattern where we are gonna have the UI layer with the main activity and the main view model. The main view model is gonna be in charge of all the UI logic that goes into main activities. For example, processing the touch events and the logic behind what needs to happen there. Here, we don't have a business layer that, we don't have any like use case type of classes, but we do have the data layer. The data layer is gonna be the title repository in this case, because all the messages that you've seen on the screen, they come from the network and the database. So we have 2 data sources. So we have the local data source with the database here and the network as the kind of remote data source.
Is there a reason we're using coroutines in this specific context? Like what would happen if we try to do this without coroutines?
Actually, that's a pretty good question, because if we take a look at the code, there we go here. If we take a look at the code, the starting code starts without coroutines. So if we take a look, for example, on main view model, you will see that whenever we want to update tabs, it's doing something without coroutines. And now I can explain a little bit what it does. But kind of the exercise of this code lab is converting all the asynchronous code that we have here in the project to use coroutines. And actually, now that you mentioned that, what we are doing here, updating tabs, what's gonna do is that it's gonna increment a counter, and it's gonna kind of simulate that something is happening in the background. So background here, if we take a look, it's actually a thread pool of 2 threads. And so like the way to execute something in the background thread, you can use executors. And that's basically, this is a way that you can create a thread pool with 2 threads. And basically here, what we are calling, it's a calling submit. And we're passing a runnable, a block of code that is gonna say, okay, run this in the background. So what it's gonna do, it's gonna sleep, it's gonna block the thread for 1 second. And then it's gonna update these tabs, which is a live data, a mutable live data. It's gonna update tabs to be whatever, and that's gonna be displayed on the screen. So that's actually something that we are gonna go in a second, and we are gonna convert these to coroutines. And of course, this code is not using coroutines. Let's see. And this is gonna be, like for using coroutines, you need to implement, add some dependencies to your project. Actually, it also there is also, if you are currently using RxJava, there is here like a library, the Kotlin Coroutines Rx, that basically it's an interop between coroutines and RxJava. You can have a bridge between those 2, and you don't have to migrate everything at once. Okay, let's move on. A little bit of theory created by Sean, also like a pretty good video in case you're interested. And one of the problems that coroutines try to solve, it's reducing the needs of callbacks. And here we are talking about the callback pattern, but I want to show this in code. And basically, coroutines is gonna simplify all that. Let me show you some code for that. So here, refresh title, which is actually what's get called whenever you tap on the screen. Let me show that code. So whenever you tap on the screen, it says on main view clicked, it's gonna update the tabs whose code we've just seen, is this one here, and it's gonna refresh the title. And refresh the title, it's gonna kind of show the spinner, and it's gonna call the repo layer and it's going to call this method called refresh title with callbacks, and it's passing a callback. Why is it passing a callback? Because the repo layer, is going to make a network request, or is going to check the database in the background thread. It is not going to execute that code in the UI thread. If we were to execute the network call in the UI thread, the spinner won't spin. That's because the UI thread is blocked and the UI is not responsive. That's why we need to move the execution to a different thread. So once that's clear, basically, if we execute this, so refresh title gets executed, spinner is going to be true. We just make a call to the repo, and nothing else happens. So here, this functions is going to return, because basically with the callback, what we are telling the repo is say, okay, refresh the title, and whenever you are done, please call me back. Basically, call me back. Yeah, you can get it like that. And basically, there are two ways the things can go. Uncompleted means like, yeah, the title was refreshed properly. Basically, spinner to false, because the title is going to be refreshed in some other way. And if there was an error, then I'm going to show a snack bar on the screen. So a couple of problems with that. The problem with callbacks is that you need indentation. It's quite difficult to read what's going on. Okay, you have a callback, and then you have to implement different methods depending on the path that request took. But then, like, some of the problems with callback is that, okay, what if I want to make another asynchronous request after this asynchronous request? I need another callback inside the callback, and then it is more difficult to read. And one of the problems as well with callbacks, if we take a look at the implementation of refresh title, it's going to make the network request, and if it's successful, it's going to update the database, is that this is happening in the background, right? So this is calling, as we were seeing before, background.submit, and it's going to do something. But this callback, whenever we call here, whenever everything goes well or there is an error, the callback is going to be executed on the background thread. But here, if we go back to the view model code, we don't have any clue that this code is being executed on the background thread. And that's for readability and for maintainability of the project, that's something really bad. And that's why here in the live data, we have to post value instead of set a value. Post value allows you to update the live data from a different thread that is not the main UI thread. So there is no guarantee that this code here is going to be executed on the main thread. And with Coroutines, we can guarantee that. Okay, I think that's fine. This is, for example, a network request. It's going to be synchronous. So it's going to be, as I here in the comment, make a network request is going to block the call. Any question, Karen? Otherwise, I'm going to start writing some Coroutines code.
Yeah, I guess one question I had is what exactly does it mean when it says that network request is going to block code? What exactly is that blocking?
Yeah, it's going to block the thread. So for example, whenever you make a network request, it might take some time to reach the server, get the response back. The server, of course, is going to take some time to process the request. And probably you need to parse the response in some way and all that. All that time where the network request reaches the outer network, the internet, that's time that your thread is going to be doing nothing. It's going to be blocked because it's waiting for the network request to come back. And if that's blocked, means that no other code can be executed in that thread. But with Coroutines, we have something that instead of blocking, it is going to suspend execution. And so whenever you hit, we are talking about suspend, is that whenever you suspend, the execution is going to suspend, but the thread is going to be free to execute other things that might happen in that thread. And when the network request comes back, then it resumes execution. It saves all the variables, it saves everything that it needs to do to resume execution after that network request comes back.
Got it. For this kind of case, what if I wanted to use an async task? Is that something that's valid? Should we still be using async tasks?
No, Async Task, it was a good solution very long time ago, but it was deprecated in Android 11. And the problem with Async Tasks is that it was really easy to leak memory. And also, actually, it was kind of attached to the life cycle of the view layer. And here we can see, and we're going to see that we can use different scopes to tie like certain requests to a different life cycle. In this case, for example, the view model.
Got it. Nice. Okay, yeah, I'm excited to see the lifecycle stuff.
Okay, let's try. I mean, I think it's 20 minutes. I haven't seen or I haven't shown any coroutines code. This is going pretty well. Okay, okay. Understanding coroutine scope. I think I'm gonna skip this, and I'm gonna probably talk through it later. But basically, we are here in the main view model, update tabs. We've seen before that this is doing something in the background thread. Let's convert this code, this specific code, which is very simple, to coroutines. Okay, here we have kind of the solution, but let me do that. Meanwhile, I'm gonna be talking through what I do. Okay, main view model. So we have these update tabs that we want to replace. And basically, whenever you want to execute something in coroutines, actually, let's do this, a private fun. I'm gonna comment this out here, and I'm gonna create the private fun update tabs, okay? And now we're gonna say that, okay, I want to execute this in a coroutine. Actually, if we see like tab count wasn't in a coroutine, so we could certainly do that, kind of have the same code. And how can I do, how can I create a coroutine from the view model layer? We have something that is called coroutine scope. And the view model comes with a built-in coroutine scope, which is called view model scope. And let me talk through that later a little bit. Bear with me for a second. Basically, the background submit thing here, I can create kind of the same thing. Actually, this code here, view model scope.launch, is creating a new coroutine. And a coroutine, you can think of it as an easy way, like for example, whenever here we have background.submit that we're passing a runnable, kind of you can think of coroutines as in the same way. You can think of a coroutine as a runnable with superpowers. With superpowers, because we will see that it is really easy to do things with the background execution as well. So here we actually can do exactly the same thing, and we're gonna see the differences in a second. Okay, so we have thread.sleep, and I say, hey, don't do this because this is gonna block the thread. Sure. And probably I can do the same. So we are starting with exactly the same code, and we are gonna improve it. Okay, so what is view model scope? So I was saying like every coroutine needs to live in a specific scope. And the coroutine scope is if we take a look at the definition, well, it doesn't matter. A coroutine scope, it's going to be the entry point. It's the way you can create a coroutine. And basically, with a coroutine scope, you can get track of all the coroutines that have been created with this specific scope. So here, we are not in a coroutine. Here, we created a coroutine. One of the things here to take into account is that view model scope is configured with dispatchers.main. And dispatchers.main, I'm going to put that here. Dispatchers.main, it's going to execute something on the main thread. So basically, launch, I say, okay, I want to execute this coroutine on dispatchers.main. But this is not what we were doing here, right? Here we were executing on a different thread. So the way to create a coroutine that executes on a different thread, so we have different dispatchers. Dispatchers mainly tell the coroutine where to run. And we have one which is default. Default is a thread pool that is already configured in coroutines, and it has a number of threads that you can use to run things in the background. So basically here we just created a coroutine that is gonna be executed on a background thread pool. So obviously, if we do this, if we execute this block of code in main, and if we sleep the thread, that's going to be pretty bad because it's going to block the main thread. But here, it's kind of okay, but it's not okay because obviously you shouldn't be blocking any thread because otherwise that thread becomes useless. It's going to become there and it's going to cannot be used. However, there is a way to sleep in coroutines. And that's with the delay function. And delay, if we take a look, it's a suspend function that is gonna, kind of delay the execution of this block of code for a second, and then it's gonna execute this bit. So what does it mean that it's a suspend function? And here actually you can see the gutter icon that means that this is a suspend function. A suspend function means that the execution of this coroutine can suspend. And this is what delay does. So whenever you execute this coroutine on the background thread, it is gonna wait for 1 second, but it is not gonna block the thread. Thread.sleep was blocking the thread, but delay, it's gonna suspend the execution. What that means is that while we are waiting for 1 second, other code can be executed on this thread. And whenever that second passes, then this code will be executed. The coroutines is smart to know when to resume and suspend the execution of a certain block of code. But something we can do as well, because here we can say, okay, I want to execute this in main. This code here, it is not gonna block the main UI thread. It is gonna suspend execution. So actually, this is safe to call from the main UI thread because it's gonna suspend, it's not gonna block. And so here, instead of saying post value, we can actually call value and assign tabs.value. We can assign it directly because it's guaranteed that this code is going to be executed on the main thread because we executed it here. Something to keep in mind is that view model scope by default is gonna use dispatchers.main. So this is a little bit redundant. So if we call this block of code is gonna be executed on the main thread. Okay, we created our first coroutine. Any questions, Karen?
Yeah, I think you already touched on this a bit, but someone in the live chat was wondering, how do they know the behavior of the default dispatcher in that launch function? And I think you said it was, oh, yeah.
Yeah, the default dispatcher, it's pre-configured in Coroutine. So we have, here you can see there are 4 dispatchers available. So there is default, that it's basically for things that need to happen in the background thread. Then we have IO, which is specifically used for intensive IO operations, like for example, network or disk. And we have an unconfined, which it's something that as a beginner, you shouldn't worry about. It is not commonly used and not in production code that much. So default for CPU intensive tasks, main for things that need to be executed on the main thread or of things that are non-blocking, and then IO for the rest. And actually, you can go into the kind of the implementation, but it uses like a default scheduler that in this case is using like 64 threads and things like that. So you don't have to worry about that. That's pre-configured for you, and that's ready to go, ready to be used.
Nice. I think there was another question about what would be the right way to call a suspend function on the main thread.
Okay, if you want to call a suspend function from the main thread, that's it. You create a coroutine with view model scope, for example, view model scope.launch, and that will be executed. And that's basically how you create a coroutine on the main thread from the view model scope. We will see later that also the view layer has a different scope. And so I was saying like the coroutine scope here is quite important because imagine like you are doing like a really long operation. Imagine something that is very expensive and it's taking a lot of time. Imagine it's going to take 10 minutes or whatever it is. Obviously, this can leak memory. Because if you have, if you are doing something crazy and then here you are referencing it to something else, until all of this doesn't finish, this runnable or this coroutine is going to be in memory. The good thing about the predefined scopes is that whenever the view model scope in this way, is that whenever the view model goes away, gets destroyed in unclear, this view model scope is going to get destroyed, meaning that all the coroutines that it's executing, they are going to cancel. Obviously, view model scope, you can create your own scope if you want. Like, for example, we can call my scope, it's equals to a coroutine scope. And basically, the coroutine scope is going to take a coroutine context, as you can see here. And the coroutine context is basically like a set of elements that is going to configure the coroutine. And for example, one way to configure it is say, okay, what is the default dispatchers? So view model scope in this case is using dispatchers.main, but also it has something like a job. And probably if we have time, we will explain later what a job is. But basically, view model scope is mainly this. It's configured with a supervisor job and dispatchers.main. So every coroutine that you create using my scope or view model scope, it will be executed by default on the main thread. And then, of course, then in a view model, you get the onClear, that you can know when the view model is going to be destroyed. And basically, what view model scope is doing under the hood, and we can do with MyScope, is that you can call MyScope.cancel to actually cancel all the coroutines that are executing at this time. And for example, this one that is taking 10 minutes, it's gonna be canceled because we canceled its scope. So this is a good way to not leak memory and make sure that you wrap up and clean up everything whenever the view model in this case goes away.
So by using the default scope, we don't have to specifically call cancel ourselves when the view model is cleared.
That's right. View model scope is doing that under the hood, and that's why it's an easy way to get started with coroutines. Otherwise, you would have to create your own scope and clear it in all your view models. If you use view model scope, that boilerplate goes away because everything is done for you.
Cool. Thanks for clarifying that.
Okay, so actually something worth mentioning is that there are some questions and some confusion regarding when do you create a coroutine scope, in which layer. Basically, I recommend creating a coroutine scope whenever you want to control the life cycle of coroutines. Basically, I would create a coroutine scope for the view model layer because that's kind of attached to the view life cycle, and it knows when the screen is gonna go to the background. The view model scope survives configuration changes. So in Android, the view model scope, it's a natural place to start creating coroutines. But then if we go, for example, to the repo layer, a repo layer, if it's doing an operation that is linked to the screen, as we are gonna do right now, it doesn't need to create a coroutine scope. It just can expose suspend functions, and we will see in a second. Actually, let's move into that and do that. I mean, we're not following the code lab that much, to be honest, but we are roughly here in section 5, where we created a coroutine here. Okay, I think we're gonna talk now about section number 7, and we are gonna basically convert this refresh title into coroutine. So basically, what we are doing, I'm gonna copy this code, a refresh title. I'm gonna copy that into my Android Studio here in main view model. So basically, as we were saying, coroutines read sequentially. We were saying before that coroutines are gonna remove the need for callbacks. And that's because in the callback, you are saying, okay, whenever you are ready, whenever you finish your work, then execute the callback that I'm passing to you. And that's because their mechanism works in that way. But with coroutines, instead of calling a callback, we can suspend our execution until that work finishes. And that's what we are gonna do right now. So refresh title, obviously, let me comment this out. Refresh title here, the previous implementation is using callbacks, but with coroutines, actually we are executing this on the main thread. We are showing the spinner, we are calling the repo, and then in case there is an error, I want to show the snack bar. And finally, whenever the refresh title function returns, then we put the spinner to false because we finished loading the items. So you can see, like with coroutines, we will see later that refresh title, it's gonna be a suspend function. So whenever you call repo refresh title, this block of code is gonna suspend execution until refresh title finishes. So there is no need for callbacks because the next line of code here, next line, will be called when repo finishes, refreshing the title. So that's pretty neat. And that's why, like, you can see, like, all the complexity that we have here with callbacks, that complexity goes away. Like, you can read this function, you can read this coroutine, and it reads sequential. Like, everything has a sense. One thing gets executed after the other. Okay, refresh title. How, basically, it's complaining because we don't have a refresh title, but let's create that now. So I'm going to create a suspend function, refresh title. And this one is not taking any parameters, right? Yeah. So as you can see, like, I created the suspend function, and now the gutter icon appeared. It means that this coroutine can suspend execution. Okay, so suspend function, the suspend keyword here, basically, we are telling the Kotlin compiler that this code needs to be executed in a coroutine. And that's just by simply having the suspend keyword there. This function cannot be executed from a regular function. For example, if we come here, we are here in refresh title from the new model. Here, I'm not in a coroutine, and I cannot call refresh title because it's going to give me an error and say, hey, refresh title is a suspend function that needs to be called from within a coroutine. And that's basically how we guarantee that these coroutine-specific functions run on a coroutine. Okay, so let's go back here. We're pretty much going to do the same exercise that we've been doing before. We have the code here. We're going to convert it to a coroutine. So basically, I'm not going to submit this runnable or this work or this block of code into the background thread. I'm going to execute that code in a coroutine. So basically, of course, now what happens with the callback? Well, we don't need a callback because basically this is going to return whenever it finishes. So because this is the kind of this is a little bit harder to read because we have pretty much zooming, but basically instead of calling onCompleted, we don't do anything. The function is going to return. The suspend function is going to return because there is nothing else to do. And instead of calling the callback with an error, something we can do is instead throw an exception. So we can say, okay, I want to throw here the title refresh error if I couldn't be able to refresh the title. And pretty much the same here. So if that happens, throw the exception. So you can see, this actually reads pretty well. So I'm going to try do something. Here, I'm going to make this network request that this is synchronous. We will see later how to avoid this. And here, if it's successful, I'm going to insert the title in the database. And if not, I'm going to throw an exception that the coroutine is going to catch. We will see later that actually this refresh title has a try catch. So here, it will come to this path. OK. If I don't do anything, if I don't code anything here, this suspend function is going to be executed on the same thread where the coroutines has been launched. And in this case, because this was launched in dispatchers.main, this coroutine is going to go to the main UI thread on Android, and this is going to block the thread because this is a blocking call. Something we can do to move the execution to a different thread is using a function in Coroutines where it's called with context. And with context, basically what we are doing, it's saying, okay, this piece of code that I'm going to tell you, execute it in a different context. So something we can do is that dispatchers, because we are doing a network request, I can certainly have that in an IO dispatcher. So execute this block of code that I'm passing you in the IO thread. And now this is safe to be called from the main UI thread. So this is called from the UI thread. Whenever it comes here, I'm gonna swap the execution of this coroutine to be done in the IO. So now all of this is gonna be in the IO thread. If we take a look at with context, what it does is that it's a suspend function, meaning that it's gonna suspend execution, and actually the coroutine that calls this function it is going to wait for this block of code to finish before returning. So something like we can do instead, like here, I want it to be clever, and it doesn't read very well. But something I can do, it's doing that, refresh title, and basically, I can call with context inside this coroutine. So here, this executes on the calling dispatcher. Actually, this will be this part of the coroutine, this part of the block of code will execute on main thread. And now I'm swapping to the IO thread. And all of this is going to be executed on an IO thread, on a thread pool that is configured for that. Obviously, still, this is a blocking call. It will block the IO thread, but it won't block the main UI thread. That is what we care about in Android. Cool. Any question, Karen?
Yeah, I think Myra had a question about what's the difference between blocking and suspending a thread? Because a lot of times you're saying something is being blocked, and then you're like, hey, we're going to create a suspend function. So can you kind of give us a more in-depth mental model of that?
Sure. So here, as I was saying, with context, it's going to suspend execution. And I was saying, like, after, OK, this is a pretty long line of code. Let me see if I can do this. OK, so with context here, this is going to suspend execution until all of that in here finishes, meaning that now with context only that here, like this is going to execute on the calling dispatcher as well, right? So what that means with suspend is that here I'm executing on the main thread. The coroutine is executed on the main thread. Now I come here, and it's going to suspend execution until all of that finishes. What that means is that whenever it comes here, it is going to be on the main thread as well. But the coroutine, the execution, suspended while all this code was happening on the IO thread. And because it's suspended, it means that now the UI thread, the main UI thread that was the calling dispatcher, is free to do other work. And so meanwhile, the IO request is happening, the UI thread can still spin the spinner that we have. And so basically suspending means that, hey, I'm going to park this block of code that I'm executing. I'm going to put it in a specific bucket for later. I'm going to be executing other things that are being dispatched to my thread. And whenever the IO finishes, whenever like this piece of code here finishes, then I'm going to take that coroutine back and I'm going to continue the execution. If we see like the blocking call, if this was a blocking call, that wouldn't happen. So if this is blocking, the UI thread wouldn't be able to do anything else. It will be blocked. The spinner won't be able to spin because the thread is busy waiting for the IO request to come back. Versus with a coroutine, with the suspend behavior, it's free to do whatever it wants to do, and then it will go back to that execution that was left in the middle, and then carry on executing. And it's what it's called. It is going to resume executing. So resume executing on the main thread.
Got it. That makes a lot more sense. And then Shiv had a follow-up question. Is it guaranteed that the same thread will resume the execution after it got suspended, or are we not sure about that?
Right. So the main thread is dispatchers.main is configured with one thread. So here, because we were saying that default has 64 threads, if we do dispatchers.io here, and then we do with context again, with dispatchers.io here, obviously this is executed on main. It is not guaranteed that the code that executed this is going to execute this as well. It could be a different thread. So whenever you create whenever like something you use with context and passing a dispatchers, but basically under the hood in the Android runtime, this is going to be a runnable as well. And the runnable is going to be dispatched to the thread pool. And then the thread pool is going to decide which thread to use. It could be the same thread, it could be a different one. But there is no guarantee that it will be using the same thread, even though it's in the same coroutine. And so that's why you have to keep in mind that there are like concurrency problems that could happen if you start executing things on different threads.
Got it.
Is that
That
clear?
makes sense. Yeah, that makes it a little more clear. And then I think one other question that Neo asked that I was also curious about is, I know you were throwing some exceptions to handle errors. Is that the best way to handle errors in coroutines?
Yeah, like if you don't, I mean, here, basically we are returning unit. We are not returning nothing. If that's the case, throwing errors is the best case. If not, you can use like some kind of more like functional construct, like returning a result class. And the result class could be either success or could be an error. And so that's a way that you can avoid throwing exceptions.
Got it. Cool. Thanks.
Cool. Okay, let's continue because we were saying that right now here, we are blocking one of the IO threads with this network request. But turns out that Coroutines has a pretty good adoption in the community, and we have Room that supports Coroutines and also Retrofit. That is a pretty popular solution for networking on Android. So basically, what we are going to do is actually convert those calls into coroutines. So let's start with Room first. So here we are inserting a title, and if we see the DAO, basically it's a kind of this is a blocking call. If the way we can make it coroutines friendly, because Room has support for coroutines, is as simply as having the suspend modifier here. So basically, just by doing this, we are saying, hey, this function can be called from a coroutine. What's even better is that Room, under the hood, it is going to make this function main safe. That means that you can call this function from the main thread, and Room, because it's in a coroutine, it's going to swap the execution to an IO thread. So you don't have to worry about the blocking there, because that's going to be executed on a different thread automatically. And that's for Room. And then the same thing can be said about Retrofit. Retrofit also supports coroutines. So basically, instead of having here a blocking call, we can have a suspend function, fetch next title, and instead of returning a call that then you call execute to execute synchronously, you don't return anything. You just return what it needs to return. In this case, the object that you're getting. In this case, a string. And now, if we go back, so basically, we just converted Retrofit and Room to support coroutines. This is something that the library handles for you. You just need the suspend modifier there. If we go back to title repo, means like, yeah, now like you are not getting like the execute here, you're not getting a callback. This is not a blocking call anymore, using a suspend call. So here, basically, I don't get the result. I get the actual title itself, because if there was an error, it is going to throw an exception. That's how Retrofit does it. So basically here, I can remove all this code and actually call passing in the title here. So basically, now you can see the getter icon. If we read this, we can say, okay, we move the execution to the IO thread. Now I want to catch an exception that could happen, and it reads sequentially. I'm going to make a network request whenever, so the network request is going to be executed in the background, and because I'm in a coroutine, this block of code, it's going to suspend until the network request comes back, because it's a suspend call. And whenever it comes back with the result of that network request that we can inline here very easily, then I'm going to call the Room database. I'm going to insert this, which is a suspend function as well. And so this is going to, like this next line here, it's going to be executed after Room successfully added the title to the database. So everything is asynchronous code. It can happen on different threads, but in a coroutine, you read everything sequentially, as if as if it was a synchronous call, but it is not. So okay, even better, we were talking before that Retrofit and Room are gonna be main safe. That means that they are safe to call from the main thread, and therefore we don't actually need to move to the IO dispatcher. We can remove all of this and call all of this from the main thread, because we are sure that the main thread, it is not going to be blocked. This execution is going to suspend. It is going to be, waiting until everything happens on a different thread. And actually, this is still true. It's going to resume on the main thread, but you can see how much we've simplified the code with coroutines. So the previous implementation was something like this. Now this doesn't compile anymore, but look at how many lines of code with very difficult to read code. And now we have like 2 lines for our business logic, and then one line to catch the exception. Isn't it cool?
Nice.
Cool. So yeah, that was pretty much how we converted all of that into coroutines. And here again, like it's safe, we can call like viewModel scope to trigger the coroutine. And the good thing as well about this is that this can be called from anywhere. So because this is a suspend function, now this is a kind of reusable piece of logic that can be executed in a coroutine. So we can call it from the viewModel as many times as we want, and it's going to suspend execution until everything is finished.
Cool. Yeah, I think as we're watching you go through all this, some people have questions about, are there any limitations to coroutines? Like, can we do very intensive network calls, things that might be taking a long time? Are there any limitations when using coroutines?
There are no limitations, but something to keep in mind, and probably, I think this is in the code lab, but let me step away from the code lab a little bit and create kind of a difficult situation. So imagine that we have a suspend function that we are going to call read files. And imagine that we have a huge list of files that we want to, let's say, files, something like that. Let's do nothing here. So basically, imagine that we have a huge list of files that we want to read. And so something that we could do, it's having like a for loop for file, in files, then do something. There are things that we can do here to better improve this. Like we could parallelize reading the files, but just try to see something like, okay, I'm gonna read the file and parse it. And actually, this can take a lot of time. Like imagine if you have hundreds of files, this could run forever, basically. And because this potentially could be blocking code, you need to make sure that whenever the coroutine is suspended, whenever the coroutine gets the cancellation signal from the main view model, for example, we need to make sure that our very intensive piece of logic is able to respond for cancellation. And that's a good practice. And something like you can use, for example, it's called, for example, ensure active. It's a context. Where was that suspend function? I think it was ensure active. Is active? I don't know anymore. Actually, I don't know why this doesn't work. When something of this happens, is actually you can go back to the coroutines things I was saying, and we have a blog post for cancellation. It's cancellation in coroutines that Florina wrote, and we are saying different things like how you can handle cancellation. Actually, ensure active should be there. I don't know why it doesn't come up. I don't know. It should work. Context. Yeah, I don't know why it didn't work, but I think here where we are, for example, okay, something that we can do. Yeah. So imagine like we want to run all this code in dispatchers.io, right? So basically, I want to read the files in dispatchers.io, but I want to listen for that cancellation signal. So here, basically, you can call ensure active, that it's gonna make sure that the coroutine is still alive. It didn't receive the cancellation signal. So something that you can do, for example, is like before reading each file, say, okay, is my coroutine active or not? Because if not, if you do like multiple consecutive blocking calls, the thread is gonna be really busy reading files, and it's gonna, it's not gonna check if something is being canceled or not. Something to keep in mind is that by definition, all suspend functions in the Coroutines library are cancelable. So for example, the delay function that we were talking before, delay, if it's cancelable, that means that if delay gets the cancellation signal, then it's gonna automatically stop that delay. And that's why in the view model here, we could say, okay, you can wait for 10 minutes and then do something else. Delay is gonna be, listening for cancellation. So if the view model scope gets canceled, this execution will be canceled too. But if you do very intensive and heavy work, make sure to be cooperative with cancellation and make sure to check that you are not canceled.
Got it. I think that kind of brings up the second question someone had, which is there a built-in way to retry these functions if they get canceled? Like what's the best way to handle these errors if a function doesn't complete?
Right. So that's a different, there is no way to check for that. So let me go back. That's a complicated question. And there is something here in the additional resources for Kotlin Coroutines that I was showing before in the documentation. I have a blog post about patterns for work that shouldn't be canceled. And that's gonna give you an idea of how to do this. Because obviously, if you are here, there is no way that you can do that. There are like certain ways that are not very good. One solution, which you shouldn't use, it's using non-cancelable, but that's not safe to use. And in the blog post, I cover why non-cancelable is not a good option. If you read the blog post, you will see that the recommendation is actually executing the block of code that you don't want to listen for the cancellation coming from the scope that is being calling the coroutine, and use a different coroutine scope instead.
Got it. Makes sense. Well, we didn't actually get through much of the collab, but it looks like we are about to run out of time. So what would you suggest people do if they want to learn more about coroutines or if they want to try this out themselves?
Right. I think the code lab, we didn't actually follow the code lab, but pretty much everything that we wanted to cover, we've covered it. Something that is missing is testing. So I would recommend people at their own pace, go through the code lab. Also, check out the documentation. As I was saying, the documentation is pretty good. We've been updating it very recently. So the overview is also like for people that know nothing about coroutines. Whenever you are more comfortable with coroutines and know what to do, check out the coroutines best practices documentation for things for things that you should and shouldn't do. And yeah, like this additional resources page is a good one to know what you don't know about coroutines. So here we have a lot of things in the table of contents like, hey, I want to learn more about exceptions. I want to learn more about cancellation, about how coroutines integrates with Jetpack libraries. I highly recommend going through our documentation. And if you're interested in more topics, check out the additional resources, or actually you can reach out to us directly and we will be able to point you at the right direction.
Awesome. Yeah. Thanks, Manuel, for all those pointers. And thank you all for joining for our first episode of Android Go-Along. Hopefully you found this helpful in getting started with coroutines. Hopefully you'll have some time to try out using coroutines yourself. But be sure to subscribe to our Android developers channel for more information about our next live streams. Otherwise, thank you all so much for joining this first episode.
Thank you for joining. Bye.